A group of 110 students of grade 12 were asked which sports they played. The results are below. F is equal to students who played football, B is equal to students who played basketball, and S is equal to students who play softball. 14 students play football only, 11 students play softball only, 15 students play football and basketball only, 21 students play all three sports, 13 students play none of these sports, X students play football and softball only, 2X students play basketball and softball only, and 3X students play basketball only. Copy and complete the Venn diagram using the above information. And so here we have this Venn diagram, and our goal is to complete this Venn diagram using this information that we have. And so let's go ahead and do it. Notice that they say that 21 students play all three sports. And so we put 21 here. Next, they say that 14 students play football only. So we put 14 here because this represents football only. Next, they said that 3X students play basketball only. And so we put 3X here because this represents basketball only. Next, they said that 2X students play basketball and softball only. And so this part right here represents basketball, B, and softball only right here. So that's where we put 2X. And notice that they said that 13 students play none of these sports. That's why we have 13 here on the outside of these three circles. And so what we have to do here is we have to form an equation and solve it to find the value of X. If we look at our Venn diagram, we have that 14 plus 15 plus 3X plus X plus 21 plus 2X plus 11 plus 13 is equal to 110. And why we say 110? Because it says that a group of 110 students. And so that means that 14, 15, 3X, X, 21, 2X, 11, and 13 all add up together must be equal to 110. Let's group our like terms. We put all of the numbers together. We put all of the terms that have X together, and we have to simplify. So we have 14 plus 15 plus 21 plus 11 plus 13. That gives us 74. And we put 3X plus 2X right here, and we set that equal to 110. Next, we simplify these terms. We have 3X plus X plus 2X, and that gives us 6X. That's 3X plus X plus 2X, that gives us 6X. And so we have 74 plus 6X is equal to 110. Next, we take 74 and we send it over the equal sign. It was positive, but it becomes a negative when we send it over the equal sign. So we have 6X is equal to 110 minus 74. We subtract these two, and when we subtract them, we get 36. And so we have 6X is equal to, and so we have 6X is equal to 36. We divide both sides of this equation by 6. This 6 cancels out with this 6, and so we are left with X is equal to 36 divided by 6, and 36 divided by 6 is 6, so X is equal to 6. And so the value of X is definitely 6. Now, since we know what the value of X is, let us figure out what 3X is, 2X is, and what this is supposed to be here. And so we say, okay, well, we know what X is 6. We say 3X, well, we know what 3X is, that's gonna be 3 times X. And we know that X is 6, so it's gonna be 3 times 6, which is 18. And then we have 2X, well, 2X is 2 times X, and 2 times X is 2 times 6 because 6 is X, and 2 times 6 is 12. And so what we have here is 14, 15, 18, because that's 3X, 12, 6, 21, 6, 12, 11, and 13. Now they want us to find the number of students who play basketball. The number of students who play basketball. Well, the number of students who play basketball is in this particular circle, right? The number of students who play basketball is in this particular circle. And so that means that we have 21. So we have 21 plus 15 plus 18 plus 12. And we have to add them together. So that's 21, 15, 18, and 12. When we add them together, we get 66. So the number of students who play basketball is going to be 66. Next, it says find the number of elements in B intersects S. Again, find the number of elements in B intersect S. Now, what is B intersect S? Well, B intersect S, let's highlight that. So this is B and this is S. And B intersect S is highlighted here. So this is B intersect S right here. And so what we have here is B intersect S. The number of elements in B intersect S is going to be equal to 21 plus 12. And 21 plus 12 is 33. And so the number of elements in B intersect S is 33. Because we have 21 plus 12 and 21 plus 12 is 33. Next, we have to find the number of elements in F complement. Again, find the number of elements in F complement. Now, F complement means that we want all of the elements in the universal set, except for the elements that are in set F. Again, we want all of the elements in the universal set. We can include all of the elements in the universal set except for the elements that are in F. So we do not include the elements that are inside F. So we do not include 14, 15, 21, 6. We do not include these, right? But we can include any other number, right? So we have 18 because that's not inside F. We have 12 because that's not inside F. We have 11, we have 13 because that's not inside F. And so we add these, and so we have 18 plus 12 plus 11 plus 13, and that gives us 54. So the number of elements in F complement is going to be 54. Next, we have to determine, or we have to find the number of elements in S complement intersect F union B. So let's figure out what is F union B first, right? What is F union B? So what are the number of elements in F union B? And so F union B, let's highlight F union B. So F union B is this, right? This is F union B. F union B is all of this, right? And so that's why we have 14, 15, 18, 6, 21, and 12. And so that's why we have F union B. So 14, 15, 18, 6, 21, 12. And when we add them up together, we get that. Well, we just leave it as such. We don't find the full value. We just leave it like this. And we leave it like this because of what we're going to do afterwards. Now we have to figure out what is S complement. Well, S complement is going to be, the number of elements in S complement is going to be, well, what is S complement? S complement is all of the elements in the universal set. So that's going to be all of the elements in the universal set. So let me highlight that. All of the elements in the universal set except for the elements that are in S. So all of the elements in the universal set, except for the elements that are in S. So we cannot include any element that is inside of S. All right, so we cannot include any of that. But the other rest of the numbers that are not inside S, we can include. And so we could include 14 because 14 is not inside S. So this right here is S, right? We cannot include any of these numbers, 11, 6, 21, 12, we cannot include them. So, but we can include 14, 15, 18, and 13. Now they want the intersection of S complement and F union B complement. And so what we're gonna do is we know that 14, right, is in both of them. 14 is in the union of F and B, and 14 is also in S complement. Same thing with 15. 15 is in the union, and 15 is also in the complement of S. Same thing with 18, right? 18 is in the union of F and B, right? But 18 is also in the complement of S, all right? So those two, right? So 18, 15, and 14, right? Those are in both F union B and S complement. And so we add them. So that means that the number of elements in S complement intersect F union B is going to be 14, 15, and 18. Basically, these three numbers on the top, and that's going to be equal to 47. And so the answer here is 47, and that's the answer to this particular question.